Welcome everyone. Thank you so much for being here for coffee this morning. And I'm elated to be able to introduce Deepthi. She doesn't have a break in her teaching schedule at this time, but she emailed me and said, Rachel, I don't say I am ready to present unless I'm really ready to present, and I have a story to share. So she has made time to be here today because after years of working on her teaching and continued reiterative efforts, she has landed on something that she is going to tell us about and that she feels really works. So Deepthi was a 2019 to 2020 LAMP Fellow. So she has had the chance over the last year and a half to really work on innovative curriculum. So she heads up physics at Northwest College. So she's up, that's why the temperature is a little colder up there north in Powell right now. And in fact, the ski race that was up there near your area got canceled, I think probably because of cold. So my poor sister had to turn the ski bus back around and come back home. So yeah, so we'll go ahead and hand it over to you to tell us about layers, spirals, and extras, refining the flipped classroom approach.
Yeah. Okay. Thank you very much. So I'm going to talk about sort of an amalgamated, synthesized version of teaching that I have been refining over many years. And being a part of LAMP and the Summer Institute really helped sort of bring it all together. And I think I have sort of, come up with something that works because I can see that it's working for me. And I can envision it working for other people because it's sort of, general enough. Okay, so what I want to do was come up with something structured but flexible that, works for a lot of people. Okay. So this is an overview of the things I'm going to address, and just start off with a summary of my layered approach. So the basic idea is that students can pick from one of three customized approaches. Okay. So, sort of the goals and teaching philosophy, rationale, behind this approach and, classroom realities, what I have to deal with, especially in a community college in Wyoming. And then, it's all very well to have a theory, but how do you put it into practice? So, what are the logistics of implementing my method? And what are my policies regarding quizzes and exams, and then whether it has made a difference. Okay. Okay, so this is the summary of my layered approach, and it consists of three self-contained formats. And you might think, what's the big deal, right? You use PowerPoint slides, maybe use notes, maybe use, pretty much everybody uses a textbook, at least for reference. So what's the big deal? It's the way I use them. I don't consider PowerPoints as a supplement to my lecture. I consider all of these as self-contained formats so that students, who are not very confident don't have to toggle between different formats, and that really confuses them. When you say, look at, page 10 of your textbook, page 10 of your notes, and then the PowerPoint and then the Blackboard, it confuses them. And it uses up time and mental focus that they could otherwise be, using to, deal with the material. So this is to sort of minimize that sort of toggling between different formats. to present them as three self-contained formats. And then there are supplementary resources like videos, and I'll talk about all of that. And as I said, students can choose their own comfort level, and then once they feel confident, they can go up a level, or if they've had some personal challenges, if they were sick or working on another class, they can sort of go to the simplest level and at least catch up on the basics of the material. And also the it allows asynchronous students to learn asynchronously, because a lot of students have other responsibilities and may not be able to present in class, or if they are in class they may be sleepy because they were up till late at night. So it allows for the realities of students' lives. Okay, then I use the flipped classroom approach to deliver the material using PowerPoints. And then, okay, so my layered approach is layers, spirals, and extras. Spirals refers to coming back to the basic concepts again and again, and sort of really, making sure that students at least have a good handle on the basic uh, foundational material by the time the course is over. And the extras are the extra resources I keep on hand for the stronger, more interested students. Okay, so what do I want to accomplish? First of all, what do I think of as goals for any college level course? Physics or math or astronomy or history or anything. It should promote higher level thinking, because students come from high school and they're used to sort of memorizing and regurgitating and finding, relying on simplistic algorithmic methods to, do problems. And I want them to, um, learn how to go up Bloom's taxonomy from that simplistic, steps to more cognitively demanding approaches of synthesis and analysis, making connections and inferences between different concepts. And I also want students to see the material within the context of world history and the overall human intellectual progress. Um, so this is a quick recap of Bloom's taxonomy, uh, just to refresh your mind. So goes from the simple regurgitating levels to evaluating, thinking more deeply about the material, evaluating, analysis, synthesis, and so on. Um, so what do I see as broad outcomes for introductory physics? And this is my viewpoint. Of course, there are other, formal outcomes that are written in the syllabus and, given for administrative purposes, but what do I see as the broad outcomes? So the most difficult thing I see in an introductory physics course is to help students, to guide students develop a formalism with the intuition. What I've noticed is that physicists with a more experimental background teach in a way that helps develop intuition, and people with a more theoretical background structure their teaching that is more in lines with developing the correct, formalism, the right way to write equations, draw graphs, all that. I want to be able to do both, intuition along with formalism. And then toggle between different representations. and the verbal description, the graphical description, the mathematical description, and so on. And what I remember is that my teachers, both in high school and in college, did not stress, explicitly state the importance of doing these. They sort of expected us to know that something given as an equation could be represented in a graph, for example. But they did not explicitly tell us about the significance of, representing the same thing different ways. So I want to explicitly, guide the students to represent the same phenomena in different ways, and talk about the importance of using different representations for different types of analysis. Okay. And then, as I said, prioritize the core concepts so that they can build upon those core concepts and present them in small chunks. And the idea for this is from the Khan Academy videos, and then gradually, layer upon the foundational concepts. And this entire idea of presenting the material in layers actually came from an exercise class that I took, a fitness class, from an instructor who is unfortunately no longer at Northwest College. She was really good. And I used to be, well, I still am kind of apprehensive about, fitness. And I can imagine, students coming into class who are apprehensive about learning physics. And Tiffany made it, easy for us to learn, giving the exercises in very basic formats, and then giving us sort of additional, little tweaks, modifications we could do as we became more confident. And that's really how this idea sort of gelled in my mind about presenting the material in layers, so that students could pick the layer they were most comfortable with. Okay, and going by current pedagogical methods and research in physics education, my teaching needs to be, at least aligned with these approaches, which research has, shown to work. A flipped classroom approach that focuses on problem solving, and team-based learning, which was really emphasized in the LAMP program, and also clickers have been shown to be useful. My classrooms are small, so I don't use clickers, but in bigger classrooms, clickers would be useful. And also something I noticed when I was a student was that, people who are in the know, have the right kind of friends, get a lot of insider information, and, which other students may not get in time. And I want to make sure that the resources, the extra resources, are available to all students, and, irrespective of their social networks, and also irrespective of their financial status. So they must be accessible to, all students. And why do I, use this method? Because it supports the notion of Bloom's taxonomy, going from just kind of memorization and simple algorithms to higher methods of synthesis and analysis. Makes it easy to study for exams because the core concepts have been delineated, not just school exams, but for licentiate exams in engineering, GREs, MCATs, and so on. Okay, so what am I dealing with? There are students who have different academic expectations. There are students who need the physics knowledge for because they want to major in physics or a closely related major. Then there are other science or math majors who need physics. And then there are a few students who may be non-science majors, and they are interested in learning physics because they have either read about it, read about it in popular articles, and want to know what's going on. They may be interested in the philosophy of science, in the historical aspect, or they may be interested in very particular types of applications because they are inventors, or want to go into graphic design, and they may be music technology majors, and they may be interested in something like journalism or writing with a focus on the sciences. So again, continuing with different backgrounds, they come into the class with different academic background. Some had some physics in high school, some haven't. And then there are students with personal challenges and some which are not revealed in documentation, so I may not know. Something that is very important when presenting slides is that there needs to be a high contrast because of the incidence of color blindedness. And I have read that it's approximately 1 in 12 males, and especially because physics is highly skewed towards males, I am presuming that even a fairly small class may have a student who is has some difficulty with recognizing color contrast. It's supposed to be much less common in women. And then some students are not very confident in their academic ability, and they're apprehensive about taking physics, and people have different learning styles. And then I guess two main cognitive approaches. Some people think in a style that goes from general to specific, other people from specific to general. Okay, then the logistical issues, as I briefly mentioned, some students may need to miss class. It happens a lot here. Athletes, people in various college teams, and the flipped classroom approach assumes that people have read the material. That may not be the case. And people may not have the textbook at home, may not be able to afford buying the textbook. In Wyoming, people travel a lot, and they may get stuck somewhere because of the snow. And so the material must be accessible, at least in some form, to all these students. And then there could be issues affecting unexpected issues affecting the instructor as well, due to the weather, various, fire alarms, emergencies, things like that. Okay, so how do I realistically work towards my goal of, teaching a course in 16 weeks, given all these constraints and conditions? Okay, so this is my first layer, right? This targets approximately what I would estimate as approximately 80% of the students. The core concepts, lot of pictures. PowerPoint is a good way of representing, the physical scenarios, and then, various types of graphs, diagrams. And then I can upload videos, Khan Academy videos, then recorded class videos, copies of the syllabus, homework, and the final exam sheet with all the formulae learned in the course. When we had regular face-to-face classes, all my quizzes and exams were close book, close notes, and I gave them formulae. So, now that we are on this unusual, distance learning situation, I allow people to, look at the books, and they have to sign an honor code that they're not collaborating with anyone else, but I still give them the formulae. And students who are least confident about the material, who may be not very strong students overall, need information about services geared towards helping them. And these are given as physical paper copies, solution keys to the homework quizzes, and semester exams just before finals. And at the library reference desk, there's a copy of the textbook, again, because the books are very expensive, so that if a student needs to get a hold of the textbook, they can get a hold of the textbook um, at the library. Okay. And then there's a student solution manual, and the homework exercises are alternate. Okay, even usually I give this, even problems as homework problems. And there's also a copy of the study guide. And then layer 2, this is for students who are a bit more confident. And I provide printed notes. Of course, all these resources are available to all the students, but this is my target demographic. So the printed notes have the material in greater depth and detail, and more challenging worked examples, and similar to the harder homework exercises. And I assign a few homework exercises as group work, and then they can be like the group leaders and help the other students along. And also, when I have team-based learning activities, try to sort of spread them around so that they can serve as sort of peer tutors to the other students. Okay, so what about layer 3? Now, this is for the really exceptional students. I mean, this is geared towards the really exceptional students, and also material for students who have other interests, who are approaching physics through sort of a non-traditional format. Say somebody with a strong interest in physics, but they are a music major, so they want application, they are more interested in applications geared towards music and so on. Okay, so these are resources available in the library. Feynman series, popular science books, the great courses DVDs, and also I'm working on a file of extra proof, because sometimes a few students have asked about things like why kinetic energy is not conserved in rotation. So, proofs of certain results and theorems, and also books about scientists and some key developments in physics. Okay, and then these links are on the Moodle page in a separate sort of block, online articles related to what we are doing in class, but with a contemporary twist. So in other words, for students who are interested in how what we are learning in class relates to contemporary developments, they can look at these links, and then information about internships, research opportunities, and so on. And also something I am working on, I haven't put this up yet, links to other courses in other departments that may be of interest to the stronger physics students. And more resources in the library. So my entire philosophy is that the students who are struggling, who just need the core material and who are not confident enough to go further must have their core material easily available, and the students who want extra stuff can find it. Okay, but everybody can find it. It's just that the extra stuff is in another Moodle block and in other physical locations, mainly the library. Okay, so what about the slides? The slides go from specific to general. Image heavy. Okay, PowerPoint is a good way of putting up illustrations, graphs, and so on. And I also give short conceptual exercises. And also it's important, as I said, to point out the connection between using different forms of representation and giving students guidance in sort of toggling between different representations. Also, safety warnings. The most important thing is that, the students keep safe while, taking a course. So a sort of possible, safety warnings. If it's an astronomy course in particular, I mentioned not looking directly at the sun or through a telescope, without a filter or anything. So those are there. And very brief mentions of the underlying historical developments, foundational concepts. So very brief mentions of the background, the development of ideas. And these will be sort of fleshed out in the notes and even more in the supplemental sources in the library and, in the different, Moodle block. Then just briefly identify paradigm changes, the different regimes of applicability, classical mechanics, quantum relativity, then historical context, how certain ideas came to be, etymology of certain terms that sort of shed light on that particular topic. For example, kinematics from the Greek kinesis. And when teaching astronomy, the word L in that appears a lot in historical star names, which comes from the Arabic di. Okay, so how are exercises presented within the flipped classroom approach? Start with a conceptual exercise and give them a lot of hints at the beginning, and hints and relevant formulae, and gradually remove those guiding hints, so that they get to think about the material themselves. But at the beginning, when just presenting something, to give them some guidance, and then a few questions that may be similar in approach to those in standardized exams, GRE, and also help them get at least started with the homework questions. So the flipped classroom method sort of requires that students listen to lectures and read the books at home, but that's not realistic in at least in a community college setting. Cannot expect the vast majority of students to do that. So at least summarize the material in as illustrations with the core principles very clearly given. And then start off exercises with conceptual exercises, illustrations, what happens in certain scenarios. And then ask about how various concepts relate to everyday scenarios. How especially bring up situations that seem counterintuitive in terms of the theory. If the theory says one thing and experience seems to guide us towards an opposite. idea. So how do you reconcile the two? So this is all in the hopes of developing intuition, and then the formalism. Okay. Um, so first, give a first few sort of easy exercises with the principles and the diagrams given to them, and bit by bit remove the equations and the diagrams. Just give the after 3 or 4 of these simple exercises, then give more challenging questions without the formulae or diagrams, and let the students figure out which formula to use, and which they can draw their own diagrams later, but start off like this, okay, with some help. And with force diagrams especially, give the physical situation, then the appropriate force diagram at the beginning, and then after a few of these exercises, let students figure out the force diagrams for themselves. Okay, and then when when doing more difficult exercises that call upon synthesizing a lot of information, sort of give at a later stage especially, okay, maybe a few weeks after the concepts were initially presented. So to um, review, just a review a slide to remind students of the concepts. Okay, that's what I mean by spiral. Okay, go back when teaching more, challenging material. Keep going back and make connections with the foundational material. And the printed notes, they are available on the Moodle site, and any student who needs it could request a printed copy. Same material, um, but presented at a more challenging level, and also slightly more detailed um, descriptions of the historical progression of these ideas. Okay, a little bit more than the slides, and then a few challenging proofs in the appendices at the end of the notes. So how do I do this? Logistically, how do I do this within 16 weeks? And how do I prepare uh, for a particular topic? And this is the advice of Kathy Williams, who was a professor of educational psychology, and she retired a few years ago. And she said that the instructor needs to know 3 levels more than the students. And the notes and PowerPoint slides must be ready to go at the start of the semester, because things come up at the beginning of the semester, and you get delayed. So pretty much things must be ready to go at the start of the semester. And to sort of help or motivate me to present the material in a somewhat eloquent way, I read material directly related to the topics, or just on the broad themes covered, maybe on thinking, maybe on languages, use of language, and I read books and articles by a number of well-known writers and scientists, books and blogs. And then I look up physics education research. I especially like these resources, the Boulder PER group, and there is a physics education researcher called Mark Eichenlob, and he works with the Olympiad, physics Olympiad, and he's very focused on finding novel methods of problem solving, APT resources, and of course the LAMP resources and um, meetings, Wyoming articulation meetings. And these must be in place by the first day, because again, if you postpone these, things come up, and when you need them, they are not there. Make sure that, again, safety, that there is a first aid kit in the lab, and phone numbers. Um, I've had one small accident in lab, but I'm always aware, when there's a sort of a hands-on component, that, there could be accidents, or, also in classrooms, students could have health issues suddenly, health issues that come up, and that's no time to, look up phone numbers. So we need to have some phone numbers of emergency contacts. And then again, for students who are not very, especially for students who are not very confident of the material, they need to, be put in touch with resources available to students like that. And um, athletics, I need to know whether athletes have potential time conflicts, and all that needs to be done pretty early on in the semester, preferably, in the first week before things get too hectic. Um, and the very first day, ask the students why they are taking the course, what majors they are in, and whether they are, in a complete different major but interested in a particular topic in physics. And make sure that they can access Moodle, download videos. Then after that, after week one, there are other things to focus on. Then I keep a handout of Bloom's taxonomy ready. This is for review before exams, when I, have the students work on more challenging exercises as a exam review. Okay, so what about exams, right? So my philosophy is that they should have learned at least the foundational material and have the resources at hand, so that they can teach themselves in the future, either because they are, taking a high level class, or taking some kind of proficiency exam, standardized exam, and so on. So we are really limited to these 16 weeks, and the basic thing is to have the material accessible to the students, that, they can work on it at a later date if they, want to. What about quizzes? Quizzes, in my mind, are to test whether students have at least the basic stuff, you know, well, that they have understood the, just the very basic foundational material, because they are given just before the exam. And if I catch students not being very familiar with the, even the very basics, then I have at least a day or two to help them. So I give them 5 quizzes, take the best 3 and double the highest. So they are not worth very much. They are worth 2% of the entire course. Each quiz is worth 2% of the entire course grade. But because the highest one is doubled, it gives them some kind of motivation to do well, without just kind of blowing it off. So, divide each question into very simple parts, so I can catch where they are not getting the material. And this is where I use the Summer Institute LAMP strategies of, team-based learning. So put students into groups, or, at least have them divide into groups themselves, and hopefully with at least one strong student in each group, and work on some more challenging exercises as sort of review for the exam. And then I also give them a handout about collaborative communication, and then the handout about Bloom's taxonomy, talk about the importance of both, and then guide students in asking questions using principles of collaborative communication. So as I said, at least the foundational material by the end of the semester. In regular semesters, before we had this COVID, um, based changes to our schedules. Um, all exams and quizzes were closed book, closed notes, but I allowed students 10% extra credit on exams for correction okay, so 10% extra credit on corrections. But now, um, under the present guidelines, because exams and quizzes are open notes, open books, I don't allow corrections. Okay, I think that's fair. Again, the spiral approach comes into play when they do the extra credit, because it makes them sort of go back and review the material. Okay, and what I realize is that my approach is pretty much in line with the Universal Design for Learning guidelines, again, which I learned in the LAMP program. These are, some of the ways in which they are in line with the guidelines. Okay. Has it made a difference? I haven't done any formal studies. I haven't done any formal studies, but because these have been implemented incrementally, but I can see that it has made a positive difference. Okay. And finally, thanks to my maternal grandfather and his uncle. They are the ones who encouraged me to go into the sciences. They told me about the 1910 appearance of Comet Halley, and also impressed upon me the importance of even teaching science and math within a context of within a historical and cultural context. And the LAMP program, Tiffany, for giving me this basic idea of teaching in layers, and then students and colleagues. Okay, so that's it. I know I have taken up more time than I intended to.
Well, thank you so much, Deepthi. It was, yeah, such a wonderful thing to be able to hear that story, because I can see all of your layers of synthesis in that. And I made some, thanks for being here, Monia. And I made some notes as we were going through, and I'm sure folks have some questions, but I did really want to synthesize a couple of extremely important things that were clear in your work, Deepthi. Student choice. So students being able to choose how they learn the material, which, as you said, is deeply embedded in the universal design of learning. You give them lots of practice on the skills that you want them to be able to show you they have on the quizzes and exams. And even the quizzes were practice that allowed you to do formative assessment before the exam, so that you could see where they were with your quizzes as more of an assessment metric than an evaluation, because they're not worth very many points, which is really cool. It seems as though you're practicing the pedagogy of kindness to me, which is essentially trusting that trusting your students to give them all of the information out there. And I know Christy has an article on pedagogy of kindness that I think she would love to share. I think coaching, so learning coaching, the idea of coaching, and as we do in coaching for skiing as well, very hands-on at first, a lot of guidance at first, and then gradually withdrawing that coaching with time. Thank you for all of those big take-home messages. And we've got a few minutes for sure for questions and discussion.
Yeah, and anything that doesn't get, any questions that don't get answered today, you're free to email me.
Yes, yes.
Okay. Yeah, any questions, comments?
I had a question
Yes.
about your use of quizzes and just benchmarks to see how prepared students are for exams.
Yes.
So, what are the benefits of having? I was thinking about this while you were talking. What are the benefits of having them worth points versus not worth points? And then also, how do you decide? I know your quizzes aren't worth very much. How do you decide how much those quizzes should be worth? Just my thinking behind that is I know that if they are worth points, it leads the student to prepare more. But how do you help them to understand that it's to help them prepare for the exam?
Okay, yeah. Actually, that's something I've thought a lot about, because quite often students are overconfident of when they go into exams, and at the exam they realize that they are less certain of the material than they thought they were. So quizzes serve as a preparation for the exams, but I also realized that if the quizzes were not, essentially, let's say, worth, half a percentage point or something, because I have sort of made these little tweaks over the years, and if they are worth too little, then the students don't take them seriously. And if they are worth if they are worth more, if they are worth, let's say, a substantial fraction of, let's say, an exam grade, then students who are not very confident of the material lose a lot of points. So it's more sort of a trial and error percentage that I developed. Exams, the chapter exams, not sorry, the section exams are worth 15 percentage points each. So I have 3 section exams, and the final is comprehensive, worth 20%. Quizzes are worth 2 percentage points, and I take the best 3 out of 5 and double the highest. And that doubling the highest gives them an incentive not to blow off the quizzes. So essentially, a small number of points, but don't blow off quizzes, because if you do really well, then the points will be doubled. That will be the taken as your doubled points. So it's more or less what I achieved through trial and error. Quizzes are worth 2 percentage points of the total course grade, and section exams are 15%.
Thank you.
Anyone else? Wonderful. That means I can have a moment to get to say what stood out to you today and what are you currently thinking about?
Rachel.
Yeah. Hi, Ramesh.
Sorry, I forgot to unmute.
2020 slogan.
Yeah. So Deepthi, what type of adjustments you had to make when you switched this class entirely online? When did you teach this face to face before?
Yes. Oh, yes.
And how did you make adjustments for online teaching?
Yeah, I think the biggest adjustment I made was I allowed quizzes and exams to be open book, open notes, because when I taught classes face to face, everything was strictly closed book. They couldn't use any resources. I just gave them the formulae, and but because now I meet students face to face only in lab, which is once a week. I think it's fair if I allow them uh, to use their notes and books, but of course they have to sign and sign a statement saying that they haven't gotten help from anyone else. And also I have allowed a 15-minute discussion with me, because by the time they take quizzes and exams, I sort of know how they approach problem solving. And if I see that what they have written is sort of different from their usual approach, then I might suspect that they have gotten help from someone else, and that 15 minutes allows me to a 15-minute phone or email, conversation, or Zoom conversation that allows me to give them, essentially a small oral exam. So they're on the spot, and, they have to explain how they got from one step to another. So that's the main change that I have implemented since going online.
Thank you.
Thanks so much. So I'm going to go ahead and ask what's standing out for you or what you're chewing on right now. And we have just a few minutes to do that. So maybe just one small thing that you're chewing on. And Annie's right next to me, so hit us.
I love the presentation. Thank you. And I love the fact that you used real life, the fitness course in your teaching. I think that is something the students can relate to. It's fun. I'm kind of worried what you're doing online with that. Maybe you can do some, I don't know, home fit stuff, but I really like that you related it to what they should be doing in their real lives. It makes it understandable.
Yeah, thank you. Because I'm not a very athletic person, and when I went, it takes me a whole lot of mental, I don't know, confidence boosting to take a fitness class. It's a huge big deal for me. And when I took Tiffany's classes, I really liked her classes. And for me to say that I like a fitness class is like a huge, big, unbelievable thing. And the reason I liked them was because she made the same course accessible to people of different levels. You could do the exercises at a very simple level and gradually build up to, more challenging versions of the same exercises. And I thought, no, why not use it for physics? Because a lot of people come into physics not being very confident of themselves. So, sort of start, give students the option of learning the very core, fundamental principles, giving them a lot of practice, and then, building up to higher levels. And they have resources available to learn the material at higher levels if they so wish.
Yeah, outstanding. Thanks, Annie. Vicki, how about you? What are you chewing on?
You want me to go next, you said?
Yeah, sure.
Okay. So I've been trying to flip my classroom for a few years now, and this was a really amazing presentation of all the things that I should be thinking more about. But one thing that really stood out to me is not really about flipping, but your question about, does the result not make obvious sense? And that's one of my favorite questions. I ask that in math all the time, because that's how I say we do critical thinking in math is. And so I tell them to ask the question, does my answer make sense? But I think I want to add in your half of, does it not make obvious sense? Because that's part of what I mean by it. It's not all of what I mean by it, but it's definitely part of it. I'm also wondering what you do when students come unprepared without having gone through the material, because the first thing I saw in flipped classrooms or went to professional development we had mentioned that you can't give in. You can't let them not have been prepared. You just have to assume that they were and go forward. And I really struggled with that. So
yes, because it's nice in theory, but it doesn't work in practice. So that's why I present the basic principles in sort of summary slides. I do give them an outline of the basic principles and ask questions in a way that builds up from them. So essentially, as while they are answering the questions, they are learning the material. When does this work? When does this not work? How would you modify this if there was friction present? Is this valid representation in a real world situation? So start with more intuitive questions. So still, it's within the flipped classroom spirit. of, having students answer questions, but structure them in a sequential way so it sort of builds up the material and then get to the more challenging questions. So that takes care of students who are not prepared.
Yeah. It's outstanding. They're uncovering the concepts through their problem solving. And, for those that felt they needed to prepare ahead of time, they had access to the pre-party. Yeah, it's great. Yeah. Laura, what's standing out for you?
Well, I mean, I'm in reality kind of chewing with developing a new course, which is a little bit outside of my comfort zone, and then trying to implement some of these strategies simultaneously. So Deepthi was saying, you want to have everything ready at the beginning of the semester. Definitely not there yet. Maybe the next time I teach the course.
Yeah.
So right now it's kind of managing a little bit my expectations, I guess, for getting things done and then trying to work all these interesting strategies in, I guess, but yeah, great talk though. So thank you very much for it. So, yeah.
Yeah. And Laura, I'll just say that there's also merit to learning with your students and to being dynamic with them. So as you are moving through the process of building the course, being able to be flexible as you're seeing them accomplish goals, and then being dynamic in your curriculum development with them can actually also be outstanding. So don't be too apologetic. Since we only have a couple minutes and I want to respect time, how about everybody else debrief in the chat and tell us something that stood out? I know Barry just had to leave. He kind of did that. So shout out something that you're chewing on before you log out in the chat. And thank you so much again, Deepthi, and thank you everyone for being here.
Yeah, thank you.